Solaris by Stanisław Lem. Chapter 2. The Solarists. In the empty corridor, I stood for a moment in front of the closed door. I noticed a strip of plaster carelessly stuck on one of the panels. Penciled on it was the word man. At the sight of this faintly scribbled word, I had a sudden longing to return to Snow for company, but I thought better of it. His crazy warning still ringing in my ears, I started off down the narrow tubular passage, which was filled with the moaning of the wind. My shoulders bowed under the weight of the spacesuit. On tiptoe, half-consciously fleeing from some invisible watcher, I found 2 doors on my left and 2 more on my right. I read the occupants' names: Dr. Jabarian, Dr. Snow, Dr. Sartorius. On the 4th, there was no nameplate. I hesitated, then pressed the handle down gently and slowly opened the door. As I did so, I had a premonition, amounting almost to a certainty, that there was someone inside. I went in. There was no one. Another wide panoramic window, almost as large as the one in the cabin where I had found Snow, overhung the ocean, which, sunlit on this side, shone with an oleaginous gleam as though the waves secreted a reddish oil. A crimson glow pervaded the whole room, whose layout suggested a ship's cabin, on one side flanked by book-filled shelves. A retractable bed stood against the wall. On the other, between the numerous lockers, hung nickel frames, enclosing a series of aerial photographs stuck end to end with adhesive tape, and racks full of test tubes and retorts plugged with cotton wool. 2 tiers of white enamel boxes took up the space beneath the window. I lifted some of the lids. The boxes were crammed with all kinds of instruments, intertwined with plastic tubing. The corners of the room were occupied by a refrigerator, a tap, and a demisting device. For lack of space on the big table by the window, a microscope stood on the floor. Turning round, I saw a tall locker beside the entrance door. It was half open, filled with atmosphere suits, laboratory smocks, insulated aprons, underclothing, boots for planetary exploration, and aluminum cylinders, portable oxygen gear. 2 sets of this equipment, complete with masks, hung down from one of the knobs of the vertical bed. Everywhere there was the same chaos, a general disorder which someone had made a hasty attempt to disguise. I sniffed the air. I could detect a faint smell of chemical reagents and traces of something more acrid. Chlorine? Instinctively, I searched the ceiling for the grills over the air vents. Strips of paper attached to the bars were fluttering gently. The air was circulating normally. In order to make a relatively free space around the bed, between the bookshelves and the locker, I cleared 2 chairs of their litter of books, instruments, and tools, which I piled haphazardly on the other side of the room. I pulled out a bracket to hang up my spacesuit, took hold of the zip fastener, then let it go again. Deterred by the confused idea that I was depriving myself of a shield, I could not bring myself to remove it. Once more, I looked round the room. I checked that the door was shut tight and that it had no lock. And after a brief hesitation, I dragged some of the heaviest boxes to the doorway. Having built this temporary barricade, I freed myself from my clanking armor in 3 quick movements. A narrow looking-glass built into the locker door reflected part of the room. Out of the corner of my eye, I caught sight of something moving. I jumped, but it was only my own reflection. Underneath the spacesuit, my overalls were drenched with sweat. I took them off and pulled back a sliding door, revealing the bright tiled walls of a small bathroom. A long flat box lay in the hollow at the base of the shower. I carried it into the room. As I put it down, the spring lid flew up and disclosed a number of compartments filled with strange objects, misshapen forms in a dark metal, grotesque replicas of the instruments in the racks. Not one of the tools was usable. They were blunted, distorted, melted, as though they had been in a furnace. Strangest of all, even the porcelain handles, virtually incombustible, were twisted out of shape. Even at maximum temperature, no laboratory furnace could have melted them, only perhaps an atomic pile. I took a Geiger counter from the pocket on my spacesuit, but when I held it over the debris, it remained dumb. By now, I was wearing nothing but my underwear. I tore it off, flung it across the room, and dashed under the shower. The shock of the water did me good, turning beneath the scalding, needle-sharp jets. I scrubbed myself vigorously, splashing the walls, expelling, eradicating from my skin the thick scum of morbid apprehensions which had pervaded me since my arrival. I rummaged in the locker and found a work suit which could also be worn under an atmosphere suit. As I pocketed my few belongings, I felt something hard tucked between the pages of my notebook. It was a key, the key to my apartment down there on Earth. Absently, I turned it over in my fingers. Finally, I put it down on the table. It occurred to me suddenly that I might need a weapon. An all-purpose pocket knife was hardly sufficient for my needs, but I had nothing else, and I was not going to start searching for a gamma pistol or something else of the kind. I sat down on a tubular stool in the middle of the clear space, glad to be alone, and seeing with satisfaction that I had over half an hour to myself. By nature, I have always been scrupulous about keeping engagements, whether important or trivial. The hands of the clock, its face divided into 24 hours, pointed to 7 o'clock. The sun was setting. 0700 hours here was 2000 hours on board the Prometheus. On Mother's screens, Solaris would be nothing but an indistinct dust cloud, mingled with the stars. But what did the Prometheus matter to me now? I closed my eyes. I could hear no sound except the moaning of the ventilation pipes and a faint trickling of water from the bathroom. If I had understood correctly, it was only a short time since Jabarian had died. What had they done with his body? Had they buried it? No, that was impossible on this planet. I puzzled over the question for a long time, concentrating on the fate of the corpse. Then, realizing the absurdity of my thoughts, I began to pace up and down. My toe knocked against a canvas bag half buried under a pile of books. I bent down and picked it up. It contained a small bottle made of colored glass, so light that it might have been blown out of paper. I held it up to the window in the purplish glow of the somber twilight, now overhung by a sooty fog. What was I doing, allowing myself to be distracted by irrelevancies, by the first trifle which came to hand? I gave a start. The lights had gone out, activated by a photoelectric relay. The sun had set. What would happen next? I was so tense that the sensation of an empty space behind me became unbearable. In an attempt to pull myself together, I took a chair over to the bookshelves and chose a book familiar to me, the second volume of the early monograph by Hughes and Ugel, Historia Solaris. I rested the thick, solidly bound volume on my knees and began leafing through the pages. The discovery of Solaris dated from about 100 years before I was born. The planet orbits two suns, a red sun and a blue sun. For 45 years after its discovery, no spacecraft had visited Solaris. At that time, the Gamow-Shapley theory, that life was impossible on planets which are satellites of two solar bodies, was firmly believed. The orbit is constantly being modified by variations in the gravitational pull in the course of its revolutions around the two suns. Due to these fluctuations in gravity, the orbit is either flattened or distended, and the elements of life, if they appear, are inevitably destroyed, either by the intense heat or an extreme drop in temperature. These changes take place at intervals estimated in millions of years. Very short intervals, that is, according to the laws of astronomy and biology. Evolution takes hundreds of millions of years, if not a billion. According to the earliest calculations, in 500,000 years' time, Solaris would be drawn 1/2 of an astronomic unit nearer to its red sun, and 1,000,000 years after that would be engulfed by the incandescent star. A few decades later, however, observations seemed to suggest that the planet's orbit was in no way subject to the expected variations. It was stable, as stable as the orbit of the planets in our own solar system. The observations and calculations were reworked with great precision. They simply confirmed the original conclusions. Solaris's orbit was unstable. A modest item among the hundreds of planets discovered annually, to which official statistics devoted only a few lines defining the characteristics of their orbits, Solaris eventually began to attract special attention and attain a high rank. 4 years after this promotion, overflying the planet with the Loken and 2 auxiliary craft, the Otenskold expedition took a study of Solaris. This expedition, being in the nature of a preliminary, not to say improvised reconnaissance, the scientists were not equipped for a landing. Otenskold placed a quantity of automatic observation satellites into equatorial and polar orbit, their principal function being to measure the gravitational pull. In addition, a study was made of the planet's surface, which is covered by an ocean, dotted with innumerable flat, low-lying islands, whose combined area is less than that of Europe, although the diameter of Solaris is 1/5 greater than Earth's. These expanses of barren rocky territory, irregularly distributed, are largely concentrated in the southern hemisphere. At the same time, the composition of the atmosphere, devoid of oxygen, was analyzed, and precise measurements made of the planet's density, from which its albedo and other astronomical characteristics were determined. As was foreseeable, no trace of life was discovered, either on the islands or in the ocean. During the following 10 years, Solaris became the center of attraction for all observatories concerned with the study of this region of space, for the planet had in the meantime showed the astonishing faculty of maintaining an orbit which ought, without any shadow of doubt, to have been unstable. The problem almost developed into a scandal. Since the results of the observations could only be inaccurate, attempts were made in the interests of science to denounce and discredit various scientists, or else the computers they used. Lack of funds delayed the departure of a proper Solaris expedition for 3 years. Finally, Shanahan assembled his team and obtained 3 sea-tonnage vessels from the Institute, the largest starships of the period. A year and a half before the arrival of the expedition, which left from the region of Alpha in Aquarius, a second exploration fleet, acting in the name of the Institute, placed an automatic satellite, Luna 247, into orbit around Solaris. This satellite, after 3 successive reconstructions at roughly 10-year intervals, is still functioning today. The data it supplied confirmed beyond doubt the findings of the Otunskold expedition concerning the active character of the ocean's movements. One of Shanahan's ships remained in orbit, while the 2 others, after some preliminary attempts, landed in the southern hemisphere, in a rocky area, about 600 miles square. The work of the expedition lasted 18 months and was carried out under favorable conditions, apart from an unfortunate accident brought about by the malfunction of some apparatus. In the meantime, the scientists had split into 2 opposing camps. The bone of contention was the ocean. On the basis of the analysis, it had been accepted that the ocean was an organic formation. At that time, no one had dared call it living. But while the biologists considered it as a primitive formation, a sort of gigantic entity, a fluid cell, unique and monstrous, which they called pre-biological, surrounding the globe with a colloidal envelope several miles thick in places, the astronomers and physicists asserted that it must be an organic structure, extraordinarily evolved. According to them, the ocean possibly exceeded terrestrial organic structures in complexity, since it was capable of exerting an influence on the planet's orbital path. Certainly no other factor could be found that might explain the behavior of Solaris. Moreover, the planetophysicists had established a relationship between certain processes of the plasmic ocean and the local measurements of gravitational pull, which altered according to the matter transformations of the ocean. Consequently, it was the physicists rather than the biologists who put forward the paradoxical formulation of a plasmic mechanism, implying by this a structure possibly without life as we conceive it, but capable of performing functional activities. On an astronomic scale, it should be emphasized. It was during this quarrel, whose reverberation soon reached the ears of the most eminent authorities, that the Gamow-Shapley doctrine, unchallenged for 80 years, was shaken for the first time. There were now some who continued to support the Gamow-Shapley contentions, to the effect that the ocean had nothing to do with life, but that it was neither parabiological nor pre-biological, but a geological formation of extreme rarity, it is true, with the unique ability to stabilize the orbit of Solaris, despite the variations in the forces of attraction. The Chatelet's law was enlisted in support of this argument. To challenge this conservative attitude, new hypotheses were advanced, of which Civito Vita's was one of the most elaborate, proclaiming that the ocean was the product of a dialectical development, on the basis of its earliest pre-oceanic form, a solution of slow-reacting chemical elements, and by the force of circumstances, the threat to its existence from the changes of orbit, it had reached, in a single bound, the stage of homeostatic ocean, without passing through all the stages of terrestrial evolution, bypassing the unicellular and multicellular phases, the vegetable and the animal, the development of a nervous and cerebral system. In other words, unlike terrestrial organisms, it had not taken hundreds of millions of years to adapt itself to its environment, culminating in the first representatives of a species endowed with reason, but dominated its environment immediately. This was an original point of view. Nonetheless, the means whereby this colloidal envelope was able to stabilize the planet's orbit remained unknown. For almost a century, devices had existed capable of creating artificial magnetic and gravitational fields. They were called gravitors, but no one could even guess how this formless glue could produce an effect which the gravitors achieved by the use of complicated nuclear reactions and enormously high temperatures. The newspapers of the day, exciting the curiosity of the layman and the anger of the scientist, were full of the most improbable embroideries on the theme of the Solaris mystery. One reporter going so far as to suggest that the ocean was no less a distant relation to our electric eels. Just when a measure of success had been achieved in unraveling this problem, it turned out, as often happened subsequently in the field of Solarist studies, that the explanation replaced one enigma by another, perhaps even more baffling. Observation showed, at least, that the ocean did not react according to the same principles as our gravitors, which in any case would have been impossible, but succeeded in controlling the orbital periodicity directly. One result, among others, was the discovery of discrepancies in the measurement of time along one and the same meridian as Solaris. Thus, the ocean was not only, in a sense, aware of the Einstein-Boivia theory, it was also capable of exploiting the implications of the latter, which was more than we could say of ourselves. With the publication of this hypothesis, the scientific world was torn by one of the most violent controversies of the century. Revered and universally accepted theories foundered. The specialist literature was swamped by outrageous and heretical treatises. Sentient ocean or gravity-controlling colloid. The debate became a burning issue. All this happened several years before I was born. When I was a student, new data having accumulated in the meantime, it was already generally agreed that there was life on Solaris, even if it was limited to a single inhabitant. The second volume of Hughes and Hugel, which I was still leafing through mechanically, began with a systemization that was as ingenious as it was amusing. The table of classification comprised 3 definitions: type, polythera; class, Synctitialia; category, metamorph. It might have been thought that we knew of an infinite number of examples of the species, whereas, in reality, there was only the one, weighing, it is true, some 700 billion tons. Multicolored illustrations, picturesque graphs, analytical summaries, and spectral diagrams flickered through my fingers, explaining the type and rhythm of the fundamental transformations, as well as the chemical reactions. Rapidly, infallibly, the thick tome led the reader on to the solid ground of mathematical certitude. One might have assumed that we knew everything there was to be known about this representative of the category metamorph, which lay some hundreds of meters below the metal hull of the station, obscured at the moment by the shadows of the 4-hour night. In fact, by no means everybody was yet convinced that the ocean was actually a living creature, and still less, it goes without saying, a rational one. I put the heavy volume back on the shelf and took up the one next to it, which was in 2 parts. The first part was devoted to a resume of the countless attempts to establish contact with the ocean. I could well remember how, when I was a student, these attempts were the subject of endless anecdotes, jokes, and witticisms. Compared with the proliferation of speculative ideas which were triggered off by this problem, medieval scholasticism seemed a model of scientific enlightenment. The second part, nearly 1,500 pages long, was devoted exclusively to the bibliography of the subject. There would not have been enough room for the books themselves in the cabin in which I was sitting. The first attempts at contact were by means of specially designed electronic apparatus. The ocean itself took an active part in these operations by remodeling the instruments. All this, however, remained somewhat obscure. What exactly did the ocean's participation consist of? It modified certain elements in the submerged instruments, as a result of which the normal discharge frequency was completely disrupted, and the recording instruments registered a profusion of signals, fragmentary, indications of some outlandish activity, which in fact defeated all attempts at analysis. Did these data point to a momentary condition of stimulation, or to regular impulses correlated with the gigantic structures which the ocean was in the process of creating elsewhere, at the antipodes of the region under investigation? Had the electronic apparatus recorded the cryptic manifestation of the ocean's ancient secrets? Had it revealed its innermost workings to us? Who could tell? No two reactions to the stimuli were the same. Sometimes the instruments almost exploded under the violence of the impulses. Sometimes there was total silence. It was impossible to obtain a repetition of any previously observed phenomenon. Constantly, it seemed, the experts were on the brink of deciphering the ever-growing mass of information. Was it not, after all, with this object in mind, that computers had been built of virtually limitless capacity, such as no previous problem had ever demanded? And indeed, some results were obtained. The ocean, as a source of electric and magnetic impulses and of gravitation, expressed itself in a more or less mathematical language. Also, by calling on the most abstruse branches of statistical analysis, it was possible to classify certain frequencies in the discharges of current. Structural homologues were discovered, not unlike those already observed by physicists in that sector of science which deals with the reciprocal interaction of energy and matter, elements and compounds, the finite and the infinite. This correspondence convinced the scientists that they were confronted with a monstrous entity, endowed with reason, a protoplasmic ocean brain, enveloping the entire planet and idling its time away in extravagant, theoretical cognition about the nature of the universe. Our instruments had intercepted minute random fragments of a prodigious and everlasting monologue unfolding in the depths of this colossal brain, which was inevitably beyond our understanding. So much for the mathematicians. These hypotheses, according to some people, underestimated the resources of the human mind. They bowed to the unknown, proclaiming the ancient doctrine, arrogantly resurrected, of ignoramus et ignorabimus. Others regarded the mathematicians' hypotheses as sterile and dangerous nonsense, contributing towards the creation of a modern mythology based on the notion of this giant brain, whether plasmic or electronic, was immaterial, as the ultimate objective of existence, the very synthesis of life. Yet others, but the would-be experts were legion, and each had his own theory, a comparison of the contact school of thought with other branches of Solarist studies, in which specialization had rapidly developed, especially during the last quarter of a century, made it clear that a Solarist cybernetician had difficulty in making himself understood to a Solarist symmetriadologist. Wubeke, director of the institute when I was studying there, had asked jokingly one day, "How do you expect to communicate with the ocean when you can't even understand one another? The jest contained more than a grain of truth. The decision to categorize the ocean as a metamorph was not an arbitrary one. Its undulating surface was capable of generating extremely diverse formations, which resembled nothing ever seen on Earth, and the function of these sudden eruptions of plasmic creativity, whether adaptive, explorative, or what, remained an enigma. Lifting the heavy volume with both hands, I replaced it on the shelf and thought to myself that our scholarship, all the information accumulated in the libraries, amounted to a useless jumble of words, a sludge of statements and suppositions, that we had not progressed an inch in the 78 years since researches had begun. The situation seemed much worse now than in the time of the pioneers, since the assiduous efforts of so many years had not resulted in a single indisputable conclusion. The sum total of known facts was strictly negative. The ocean did not use machines, even though in certain circumstances it seemed capable of creating them. During the first 2 years of exploratory work, it had reproduced elements of some of the submerged instruments. Thereafter, it simply ignored the experiments we went on pursuing, as though it had lost all interest in our instruments and our activities, as though, indeed, it was no longer interested in us. It did not possess a nervous system to go on with the inventory of negative knowledge, or cells, and its structure was not protoform. It did not always react, even to the most powerful stimuli. It ignored completely, for example, the catastrophic accident which occurred during the second Gies expedition. An auxiliary rocket, falling from a height of 300,000 meters, crashed on the planet's surface, and the radioactive explosion of its nuclear reserves destroyed the plasma within a radius of 2,500 meters. Gradually, in scientific circles, the Solaris affair came to be regarded as a lost cause, notably among the administrators of the Institute, where voices had recently been raised suggesting that financial support should be withdrawn and research suspended. No one until then had dared to suggest the final liquidation of the station. Such a decision would have smacked too obviously of a defeat. But in the course of semi-official discussions, a number of scientists recommended an honorable withdrawal from Solaris. Many people in the world of science, however, especially the young, had unconsciously come to regard the affair as a touchstone of individual values. All things considered, they claimed it was not simply a question of penetrating Solarist civilization. It was essentially a test of ourselves, of the limitations of human knowledge. For some time, there was a widely held notion, zealously fostered by the daily press to the effect that the thinking ocean of Solaris was a gigantic brain, prodigiously well developed and several million years in advance of our own civilization. A sort of cosmic yogi, a sage, a symbol of omniscience, which had long ago understood the vanity of all action, and for this reason had retreated into an unbreakable silence. The notion was incorrect, for the living ocean was active. Not, it is true, according to human ideas. It did not build cities or bridges, nor did it manufacture flying machines. It did not try to reduce distances, nor was it concerned with the conquest of space. The ultimate criterion, some people thought, of man's superiority, but it was engaged in a never-ending process of transformation, an ontological autometamorphosis. There were any amount of scientific neologisms in accounts of Solarist activities. Moreover, any scientist who devotes himself to the study of Solariana has the indelible impression that he can discern fragments of an intelligent structure, perhaps endowed with genius, haphazardly mingled with outlandish phenomena, apparently the product of an unhinged mind. Thus was born the conception of the autistic ocean, as opposed to the ocean yogi. These hypotheses resurrected one of the most ancient of philosophical problems, the relation between matter and mind. and between mind and consciousness. Duhart was the first to have the audacity to maintain that the ocean possessed a consciousness. The problem, which the methodologists hastened to dub metaphysical, provoked all kinds of arguments and discussions. Was it possible for thought to exist without consciousness? Could one, in any case, apply the word thought to the processes observed in the ocean? Is a mountain only a huge stone? Is a planet an enormous mountain? Whatever the terminology, the new scale of size introduced new norms and new phenomena. The question appeared as a contemporary version of the problem of squaring the circle. Every independent thinker endeavored to register his personal contribution to the horde of Solaris studies. New theories proliferated. The ocean was evidence of a state of degeneration, of regression, following a phase of intellectual repletion. It was a deviant neoplasm, the product of the bodies of former inhabitants of the planet, whom it had devoured, swallowed up, dissolving and blending the residue into this unchanging, self-propagating form, supracellular in structure. By the white light of the fluorescent tubes, a pale imitation of terrestrial daylight, I cleared the table of its clutter of apparatus and books. Arms outstretched and my hands gripping the chromium edging, I unrolled a map of Solaris on the plastic surface and studied it at length. The living ocean had its peaks and its canyons. Its islands, which were covered with a decomposing mineral deposit, were certainly related to the nature of the ocean bed. But did it control the eruption and subsidence of the rocky formations buried in its depths? No one knew. Gazing at the big flat projection of the two hemispheres, colored in various tones of blue and purple, I experienced once again the thrill of wonder which had so often gripped me, and which I had felt as a schoolboy on learning of the existence of Solaris for the first time. Lost in contemplation of this bewildering map, my mind in a daze, I temporarily forgot the mystery surrounding Jabarian's death and the uncertainty of my own future. The different sections of the ocean were named after the scientists who had explored them. I was examining Thexol's swell, which surrounded the equatorial archipelagos, when I had a sudden sensation of being watched. I was still leaning over the map, but I no longer saw it. My limbs were in a grip of a sort of paralysis. The crates and a small locker still barricaded the door which was in front of me. It's only a robot, I told myself, yet I had not discovered any in the room, and none could have entered without my knowledge. My back and my neck seemed to be on fire. The sensation of this relentless, fixed stare was becoming unbearable. With my head shrinking between my hunched shoulders, I leant harder and harder against the table until it began slowly to slide away. The movement released me. I spun around. The room was empty. There was nothing in front of me, except the wide convex window, and beyond it, the night. But the same sensation persisted. The night stared at me in the face, amorphous, blind, infinite, without frontiers. Not a single star relieved the darkness behind the glass. I pulled the thick curtains. I had been in the station less than an hour, yet already I was showing signs of morbidity. Was it the effect of Jabarian's death? Insofar as I knew him, I had imagined that nothing could shake his nerve. Now I was no longer so sure. I stood in the middle of the room, beside the table. My breathing became more regular. I felt the sweat chill on my forehead. What was it I had been thinking about a moment ago? Yes, robots. It was surprising that I had not come across one anywhere on the station. What could have become of them all? The only one with which I had been in contact at a distance belonged to the vehicle reception services, but what about the others? I looked at my watch. It was time to rejoin Snow. I left the room. The dome was feebly lit by luminous filaments, running at the length of the ceiling. I went up to Jabarian's door and stood there, motionless. There was total silence. I gripped the handle. I had in fact no intention of going in, but the handle went down and the door opened, disclosing a chink of darkness. The lights went on. In one quick movement, I entered and silently closed the door behind me. Then I turned around. My shoulders brushed against the door panels. The room was larger than mine, a curtain decorated with little pink and blue flowers. Not regulation station equipment, but no doubt brought from Earth with his personal belongings, covered 3/4 of the panoramic window. Around the walls were bookshelves and cupboards, painted pale green with silvery highlights. Both shelves and cupboards had been emptied of their contents, which were piled into heaps amongst the furniture. At my feet, blocking the way, were 2 overturned trolleys buried beneath a heap of periodicals spilling out of bulging briefcases which had burst open. Books, with their pages splayed out fanwise, were stained with colored liquids, which had spilt from broken retorts and bottles with corroded stoppers, receptacles made of such thick glass that a single fall, even from a considerable height, could not have shattered them in such a way. Beneath the window lay an overturned desk, an anglepoise lamp crumpled underneath it. 2 legs of an upturned stool were stuck in the half-open drawers. A flood of papers of every conceivable size swamped the floor. My interest quickened as I recognized Jabarian's handwriting. As I stooped to gather together the loose sheets, I noticed that my hand was casting a double shadow. I straightened up. The pink curtain glowed brightly, traversed by a streak of incandescent, steely blue light, which was gradually widening. I pulled the curtain aside. An unbearable glare extended along the horizon, chasing before it an army of spectral shadows, which rose up from among the waves and dispersed in the direction of the station. It was the dawn. After an hour of darkness, the planet's second sun, the blue sun, was rising in the sky. The automatic switch cut off the lights as I returned to the heap of papers. The first thing I came across was a detailed description of an experiment evidently decided upon 3 weeks before. Jabarian had planned to expose the plasma to an intensive bombardment of X-rays. I gathered from the context that the paper was addressed to Sartorius, whose job it was to organize operations. What I was holding in my hand was a copy of the plan. The whiteness of the paper hurt my eyes. This new day was different from the previous one. In the warm glow of the red sun, mists overhung a black ocean, with blood-red reflections and waves. Clouds and sky were almost constantly veiled in a crimson haze. Now, the blue sun pierced the flower-printed curtain with a crystalline light. My sun-tanned hands looked gray. The room had changed. All the red reflecting objects had lost their luster and had turned a grayish-brown, whereas those which were white, green, and yellow had acquired a vivid brilliance and seemed to give off their own light. Screwing up my eyes, I risked another glance through a chink in the curtain. An expanse of molten metal trembled and shimmered under a white-hot sky. I shut my eyes and drew back. On the shelf above the wash basin, which had recently been badly chipped, I found a pair of dark glasses so big that when I put them on they covered half my face. The curtain appeared to glow with a sodium light. I went on reading, picking up the sheets of paper and arranging them on the only usable table. There were gaps in the text, and I searched in vain for the missing pages. I came across a report of experiments already carried out and learned that for 4 days running, Jabarian and Sartorius had submitted the ocean to radiation at a point 1,400 miles from the present position of the station. The use of X-rays was banned by UN convention because of their harmful effects, and I was certain that no one had sent a request to Earth for authorization to proceed with such experiments. Looking up, I caught sight of my face in the mirror of a half-open locker door. Masked by the dark glasses, it was deathly pale. The room, too, glinting with blue and white reflections, looked equally bizarre, but soon there came a prolonged screech of metal as the airtight outer shutters slid across the window. There was an instant of darkness, and then the lights came on. They seemed to me to be curiously dim. It grew hotter and hotter. The regular drone of the air conditioning was now a high-pitched whine. The station's refrigeration plant was running at full capacity. Nevertheless, the overpowering heat grew more and more intense. I heard footsteps. Someone was walking through the dome. In 2 silent strides, I reached the door. The footsteps slowed down. Whoever it was behind it. The handle moved. Automatically, without thinking, I gripped it. The pressure did not increase, nor did it relax. Neither of us, on either side of the door, said a word. We remained there, motionless, each of us holding the handle. Suddenly, it straightened up again, freeing itself from my grasp. The muffled footsteps receded. With my ear glued to the panel, I went on listening. I heard nothing more.